Good morning, also from my side. I don't know if you're copying that. I'm very happy to present Decarbonizing Under Pressure. My name is Seema Issar. I'm working as a senior advisor sustainable finance at the German Green Building Council. We are a non-profit association, and today I want to just have a look of on recent research work we've been doing on how we can bring more transition finance into the building sector. And for that, we will start with a brief reality check. So basically, we've just concluded a decade from 2015 to 2025 in which we largely failed to keep our Earth systems within safe limits. We can see that we are on track of exceeding the 1.5 climate goal, which was fixed in the Paris Climate Agreement. And we can also see that we've already surpassed 7 of 9 planetary boundaries, meaning that we are on the way to breach critical Earth systems, which are already under strain. Continuing that reality check and now focusing more on the building sector, buildings still account for around 39% of the global energy-related emissions. And if we look at Europe's building stock in general, there has been the identification that we need like 3.5 trillion euros investment in order to transform our building sector by 2030. And if we look at the building stock in Germany, the EU Commission had conducted a study and identified that 75% of the European property portfolio is actually currently classed as inefficient. But we also know with continuing urbanization that around 75% of the buildings which we will need for people to live in by 2050 are already around. So basically, it also depicts this great lever we have, because by transforming our existing building stock, we could really make the goal towards or achieve the goal for our climate ambitions. Now, if we look at the political and regulatory context, we all know that the objectives have been set not only on international level with the Paris Climate Accord, but also that goal of reaching climate neutrality has been set in the European Climate Act, and also further broken down basically for the energy, for the building sector, where in the EPBD, which is the Energy Performance of Buildings Directive, we want to improve the worst performing buildings and renovate also the public buildings. So basically, we aim to double the renovation rate by 2030. But the reality in 2026 also shows that construction costs, here depicted in Germany, have been steadily on the rise in the last few decades. So both renovation and also new construction has been increasing, and also the interest rates have been increasing continuously since the pandemic, which means that renovation and new construction have been increasingly more expensive. So in this reality which we are facing in 2026, the question is, how can we decarbonize our buildings if the capital is scarce or too expensive, and with the increasing pressure? If we look at those renovations which have been implemented in the last few years, we see that renovation measures are mostly selected considering their payback periods, when they're aligned to subsidy schemes, depending on the budget capacity of the asset owner, and also in order to be compliant to regulation. But what we see in practice is that means that often low-cost measures are being favorized, and sometimes the decarbonization impact of the measure is ignored, and that also leads to suboptimal climate outcomes. So we see the need for more transition finance, and the need to look at the impact when you're allocating capital, when you're transforming your assets. And this is often done on sectoral level or even company level, but what we wanted to do is we wanted to figure out a way to look at assets and understand how we can link the investment costs which are needed for transformation to the actual asset level and the life cycle emission reduction potential. And that's where basically transition finance comes into play. So the idea is that decisions don't happen in silos, and we need to get out of the silo to look at new ways to bring solutions on the ground. So we wanted to introduce a new way of thinking where we are looking at carbon efficiency of capital. And I'll start off here with this equation where we have the abatement impact factor. This is the factor we're basically introducing, which is basically it shows the abated kilogram CO2 equivalent per euro, which means that the higher the abatement impact factor is, the higher the abatement or the reduction of greenhouse gas emissions per invested euro. And the good thing or the cool thing about this is basically that it's linking the climate impact of a renovation measure to the capital you're investing, and that enables comparison between different technologies, different buildings, and also across portfolios. It also enables a budget-specific viewpoint. It's scalable, and it's also compatible with other ESG and transition finance logic. And it doesn't necessarily replace financial metrics, but it complements them by adding this impact measure onto it. So I'll just go back. So we have basically three aspects which we need to look at. We have the greenhouse gas abatement. We need the investment costs in order to compute the abatement impact factor. So it's basically 3 steps to come to it. And if we look at a building operations emission, it's easy to see that normally, let's say if you're not emitting, so we have greenhouse gas emissions on the y-axis, we have the time period on the x-axis, and then you can see the upper line, which goes gradually down, which is the business as usual scenario of a building's emissions if you do not renovate, and then the point where a certain renovation measure is implemented, and the bottom line, which depicts the renovation scenario. So you might ask or wonder, why is the business as usual scenario going down? It's obvious that it doesn't reach the 2050, climate neutrality by 2050. That is because we also calculate in the decarbonization which is happening in the energy sector. But obviously on asset level, in this case, it would not be enough to reach climate neutrality, so the renovation measure is necessary. Now, if we compare the business as usual scenario with the renovation scenario, and you take the integral basically, and you look at the integral of between those 2 graphs, you can calculate basically what is the abated greenhouse gas amount. And similarly, you can imagine if you're looking at different renovation measures, the lower line will be higher or lower, so in the end, the abatement effect will be larger or less large. So that is basically the first step, quantifying the abated greenhouse gas emissions. And for those of you who know accounting scopes in the building sector, we developed also 3 different approaches. We have the regulated energy demand, which is basically following the regulation or the methodology used in regulation. Then we have the operational and use energy, also factoring in user-related energy. And we also look at the comprehensive life cycle approach, because basically in a renovation measure, most of the time you're adding on new materials or you're implementing a heat pump. So that also obviously has embodied emissions. So you could also use those embodied emissions for a comprehensive life cycle approach. In the next step, you would determine the total investment costs, which where we do not factor in any operational savings, because we just want to look at the total upfront investment costs which are needed. And then it's basically bringing those two numbers together, the abated greenhouse gas emissions and the investment. And that's where the abatement impact factor, the larger the result, basically the better or the higher the impact of that certain measure. And we wanted to test it all in a real-world example. Given the time frame of the project, we were unable to find any participant lending us their portfolio, so we decided to go for a simulated multi-residential building portfolio in Germany. And we used statistical analysis of a residential building portfolio, where we saw that a lot of buildings multi-residential buildings in Germany were built between the 1950s and the 1990s. So basically we chose different construction years, we chose different building sizes. We saw that in the buildings, as usual, it's mostly either oil-heated buildings or gas-heated buildings. We took some assumptions on the replacement cycles for different building components. And using all those assumptions, we built a portfolio of 320 buildings. And then we decided which renovation measures we wanted to look at. We chose 13 different ones, going from basically full renovation up until like small individual measures like windows or facade insulation. And we decided to also model the costs, because we need those for the investment. For the upfront investment, we factored in a budget restriction, and we also looked at different regional cost factors, because construction costs in urban areas mostly are more expensive in comparison to rural areas. And putting all that together, these were our results. So for one, on this graph, you can see our 13 different renovation measures we looked at, and on the y-axis, the abatement impact factor in kilogram CO2. And what we can see here is that the heat pump and PV heat pump seem to have the highest abatement impact factor, which basically the mean at around, I think, 7.6 kilograms CO2, which means that basically €1 you're investing in a heat pump, or €1 you're investing in heat pump and solar panels would give you, over a period of 25 years, abatement of 7 kilogram per invested euro. And we saw that basically the low carbon technologies dominate, so heat pumps, but also envelope measures are quite high. So it's either windows and facade, for example, also perform relatively high, but still the low carbon technologies is basically those interventions have the higher abatement impact. And we then also took a closer look at those renovation scenarios which amortize or deliver payback within within a 25-year period, and we saw that mostly in the envelope-oriented measures, such as facade renovation and roof insulation, that mostly the non-amortizing scenarios exhibited significantly higher abatement impact factors, whereas if you're looking at the low-carbon technologies, those renovation scenarios that did amortize also had the higher transformative impact, which means that there is no, the environmental value for money does not systematically align with the financial payback period. And moving on from there, we also checked how the abatement factor differs for different asset ages. So basically, for 1953 built buildings, you can see the abatement impact is slightly higher in comparison to the later years. And we also see that oil-heated buildings have a higher abatement impact factor, or slightly higher abatement impact factor in the median in comparison to the gas-heated buildings. And we also, as I mentioned, looked at rural and urban cost differences, and obviously because rural locations are a little bit lower, it also means that the abatement impact factor in rural locations is a little higher in comparison to the urban urban buildings. So what we learned is that climate impact doesn't necessarily mean it's the fastest payback time, and energy or efficiency first measures are not sufficient, and also that low carbon technology seems to be more capital efficient in order to decarbonize. And now bringing all this to practice, and because, I mean, from the German Sustainable Building Council, we always have a viewpoint of the entire value chain of the building. We wanted to look at how can different stakeholders basically use this knowledge. And as investors and banks, you could use the abatement impact factor to prioritize your capital allocation according to, or in projects where the climate impact is basically higher per euro. And that would also strengthen that transition viewpoint, which, if you know the European taxonomy, is currently just focused on like green or sustainable economic activities and non-sustainable economic activities, but not really on those brown assets basically transforming into green. For developers, it means that you could, if you're evaluating different designs, you should calculate the climate impact of those designs, focus on renovations, and then in the end also calculate that abatement impact. For asset owners, you could add the abatement impact to your financial metrics in order to make better decisions if the budgets are tight. And policymakers could design incentives which are not renovation measure focused, but more abatement efficiency focused, avoiding basically the guidance of which renovation measure to implement, but more the focus on abatement as it is. And now the question is obviously, how can you, like, why do we need transition finance, or why do we need more transition finance? You're trying to manage the transition risk for more carbon neutrality basically in the building stock, but by that you're also mitigating physical risks and thus avoiding stranded assets in your portfolios. And now from insight to implementation, how do we go on? What are the next steps? So the DGNB, the German Sustainable Building Council, we are a non-profit association with more than 2,800 members in Europe, and thereby Europe's biggest network for sustainable buildings. And we have different initiatives focusing on different stakeholders. So if you're a district or city, you could join the Klimapositive Städte und Gemeinde initiative, or if you're a bank, we have an initiative, the Sustainable Finance in Bauen initiative, where it's looking at how can you add sustainability or sustainable buildings in your evaluation if you're financing new buildings. But we also, a second pillar is the DGNB system. It's a certification system where we've already awarded more than 10,000 buildings across the world for building sustainability. And then we also have the DGNB Academy, where we're basically sharing the knowledge we have and also training experts across different countries in order for them to know how to bring into practice the sustainability knowledge. And I've brought just a few slides on how we do this work. We have, as I mentioned, this initiative, Sustainable Finance in the Built Environment, where we've already around 14 banks who have joined, and we're trying to promote the transformation in the building sector through partnered collaboration with the banks. And we want to create a platform for banks, for the banking world, to understand how can we not only evaluate the buildings, but also how can the evaluation of buildings in the terms of risks and securities in their building, in their asset portfolios, basically involve more focusedly the sustainable quality of a building. And we also have like sustainability ratings, recognized ratings, wherein certain banks already have their own criteria, set sustainability criteria when they're financing new buildings, that they only finance them if certain sustainability criteria are actually met. And with the DGNB system, we have different criteria catalogs for the interior of buildings, for renovation, for new construction, for districts, and also outdoor spaces. So depending on which part of your building you are renovating, there are guidelines on how to make sure that they are more sustainable for the outdoor spaces. In particular, this is a system I think we've just launched 1 or 2 years ago. It's about how to design the outdoor spaces so that they are more biodiversity friendly, with like a roadmap which for German locations, what kind of plants you can use in order to attract or to make it biodiversity friendly. For neighborhoods, it's also the same thing. So basically, we always look at the environmental quality, the economic quality, and the socio-cultural quality. But with buildings itself, those 3 pillars are always supported when we also look at the technical quality of the building, the process quality. How do you ensure that all the different stakeholders in the process of designing a building are on board and has the same objective of what quality they actually want to achieve. And from the DGNB system, this economic efficiency of the abatement impact factor is a no-brainer, because we not only look at efficiency in terms of life cycle assessment, so basically the environmental efficiency, but we also look at the performance orientation, so also look at assessing the whole building's performance instead of individual measures which are being implemented. And that's where I want to also just highlight we're about to launch a new buildings and use scheme. This is especially relevant for all the existing building portfolios in Germany, where we are focusing on sustainability and resilience and making sure that it aligns to the things which banks also need. So the key components are evaluating the ESG risks and the opportunities the asset has, creating a transition plan, but not on company level, but on asset level, including basically all the measures you need to implement, making a financial plan incorporating basically the measures you are seeking to implement, and then making sure that in the management processes you have the PDCA cycle implemented, so plan, do, check, act. You're setting your goals on how your water consumption is, what your energy demand is going to be, what the operational costs are, and then basically ensuring that you're managing these factors continuously. And this leaves me at my last slide. So I think climate action will fail if we don't factor in the financial or the capital allocation and for higher abatement impact. So basically we need more discipline there. And in a world of tight margins, I think decarbonization will not go further if we always keep on traveling the same road. So that's why I have this picture. Basically, it's time to take a turn and find out new ways to go, or new pathways to find out how we can make sustainability, bring sustainability into reality. Thank you very much. If you have any questions, I'd be happy to take them, or later in the round table as well.